Okay, surds can be nasty numbers to work with, but especially if they're in the denominator. So generally what we do is we turn any surds in a denominator into a rational number, that is, a whole number. Get rid of the surd in it. And the way that we can do that is we multiply the top and the bottom by the surd. So root 2 times root 2 becomes root 2 squared, or if you like, root 4, which becomes 2. Any way you cut it, down the bottom there we end up with a whole number of 2. Up the top we now have a surd in it. So whenever you're asked to rationalise a denominator, that's what it means to do. If we have a number that has a mixture of surds and whole numbers, like 4 root 3, to rationalise that denominator I don't have to worry about the 4, that's already rational. It's only the 3. So again I square that root 3 to get 3, so it becomes 4 times 3 is 12 on the denominator. And up the top, to keep the fraction the same value, I have to also multiply 3 by root 3. So my final answer is root 3 on 12. Here's another example similar to that. This time I've got a surd on the top and the bottom. I'm not worried about the top being a surd, only the denominator. Again, the 2 is fine, it's already rational. It's only the root 5 that I've got to deal with by multiplying it by root 5 and squaring it. So up the top I end up with root 15, and at the bottom I get 2 times 5, which is 10. Sometimes you have more than one term in the top, but it's the same process. To rationalise a denominator, I multiply any surds in the denominator by themselves, which squares them and gets rid of the root. And up the top, numbers just get multiplied by that same root. And one more example. Root 3 is the thing that I'm dealing with, so I multiply the top line by root 3 and the bottom line by root 3. So everything in the top line gets multiplied by root 3. So I get 6 root 6 and 8 root 15. And the bottom becomes root 3 by root 3 is 3. And I've still got that multiplying 2 as well to deal with, so that becomes a total of 6. You might be asking, could I simplify that further because it's got a common factor in the top line? Yeah, I could. I could cancel down 2 on the top line and the bottom line and get 3 root 6 minus 4 root 15 over 3.